this section, as well as throughout the rest of this course, I'm going to be mostly using the graphing calculator, and I'll show you how to use that for graphs. Using the TI graphing calculator, we're going to start by pushing the y equals button in the upper left, just below the screen, and entering 3/2 x plus 6 beside the y1. When we push the graph button, we see a graph that looks like this. Now we're going to duplicate that over on our coordinate system by putting a dot here at -4 and a dot here at 6 and doing our best to draw a straight line between the two dots. Now the calculator does not expressly say this, however, we should know that this goes forever in both directions, which means the domain, the x's, can go forever from -infinity to infinity. Likewise, the y's go forever from -infinity to infinity. The simplicity of this one actually makes it a little confusing. If you'll take your calculator, press the y equals, we just want to type a 2 out beside the y1. Then press the graph button, and we'll duplicate that graph over on our coordinate system. You notice it goes through 2 on the y-axis and goes horizontal in both directions. Now again, it goes forever in both directions. So the domain is going to again be -infinity to infinity. The range, however, will simply be the number 2. The TI graphing calculator can only be used to graph expressions that begin with a y equals. Now, since this one does not begin with a y equals, that means we can't use our calculator. The idea of this is that if you have an equal sign here, then the graph must be a straight line. It is not the dot right here. The dot right there is 5, 0, the point 5, 0. X equals 5 is a straight line. Well, the title of this slide here kind of gives you a clue as to what the graph should look like. So here, where x equals 5, there's going to be a line going straight up and straight down forever in both directions, meaning the domain for this one is only the number 5, and the range is all the numbers from -infinity to infinity. To use our TI graphing calculator, our equation has to begin with a y equals. To make that happen, we need to solve for y in our equation. So if we begin by subtracting 3x from both sides, then dividing by 4, we get what we need. This is something we can type into our calculator, and it's the same equation that we started with, just with a different look. So we'll take out our calculator, type the y equals -3/4 x, and press the graph button. This is what we see. It's evident that there is a dot at 0, 0, right in the middle. However, it's difficult to look at that graph and determine where other dots are. So you can use a table of values. You get a table of values by pushing the second graph button. The graph key has the word table up above it. If you push the second and the graph button, you get a table of values. You can use nice values from that table, or you can use some of the weirder ones. I would stay with the nice ones. So we have a dot at 4 and -3. And then we have the line that goes through those dots. Now, like before, this line is going infinitely in both directions. So again, we have a domain of -infinity to infinity and a range of -infinity to infinity. The slope formula is on the official college algebra formula sheet, which you could print from my TC and have one to carry around with you, or you can write down the formula that I'm about to give you. The slope formula looks like this: y2 minus y1 over x2 minus x1. Y is on top, x is on bottom. Now, to use that, each set of ordered pairs are coordinates. The first one is the x, and the second one is the y. We will number these first coordinates with 1s, and we'll number the second one with 2s. So this is what we mean by the formula y2, -6, minus y1, which is 4. x2 minus x1. On the top, -6 minus 4 is -10. 2 minus -2 is 2 plus 2. This simplifies to 5 halves. So there's the slope of that line. In the second one, we have y2 minus y1, x2 minus x1. That's a 0 divided by 8. You can do this on your calculator if you get confused about the zeros, and it'll tell you that's a 0. The last one, y2 minus y1, x2 minus x1. This is 10 plus 10 on top. This is -4 plus 4 on bottom. Now, unlike the one up above, 20 divided by 0 is undefined. In fact, that's what we say about the slope of that line. It is undefined. Like a previous problem we did, to graph this using our calculator, we will need to solve for the y. So if we subtract 2x from both sides, that's going to disappear, leaving the -5y. Now on the right, there's nothing that can be put together. So when we have a 10 and a minus 2x, we just have a 10 and a minus 2x. So we'll write that as a -2x plus 10. We'll divide both sides by -5, and that will give y. We can put the -5 with each of these, splitting this into 2 fractions. This is a positive 2/5 x, and this is a -2. So that is how we would type it in our calculator. If I take out my calculator, push the y equals button, type 2/5 x minus 2, and draw the graph, I see this graph on my calculator. To find the slope, we will locate a couple of points on this graph and count up 2, to the right 5. So the slope is 2/5. Notice we don't have an equation to enter into our calculator, so we will graph this line the old-fashioned way. We need to put a dot at -2, -3. Now here's -2, -3. Now from that dot, we need to count up 4 and to the right 3. So 1, 2, 3, 4 up, 1, 2, 3 to the right gives us our second dot. And we connect those dots with a straight line to get the graph.